Back on LeetCode, boys. Hopefully we complete something today. Yeah. Complete something. Okay. All right, let's get it. So today I'll be completing all of the 1D dynamic programming. Let's see. Okay. So we have here coin change, pretty famous problem, pretty popular in interviews. Let's get it. Okay. And the number of coins here are infinite. Like for every denomination, you can assume there are infinite number of coins. And we have to make exactly the given amount. That is the problem. Now let's see here. Now for example, we have coins 1, 2 and 5 and amount we have to make is 11. One way to do is using recursion. So at every coin we have two choices. Either we include this in the amount or we don't include and move on to the next coin. But the time complexity of this will be way too much. So we can't be doing that. Another way is dynamic programming, which is we will start making amount from 0. Like how many ways do we have to make amount 0? There are 0 ways, right? So yeah, we'll simply make a DP array of size amount. This is 0. Then for 1 we go to each coin and see if we can make 1 here. So if I take 1 coin, I can make 1 in one way, right? Then at 1, can I make one amount with a coin of size 2? I cannot, so I move to the next amount. Now this will be basically the DP equation would be DP of I, where I is the amount, equals minimum of DP of I and 1 plus DP of I minus C, where C is the current coin that I am looking at. Assuming I minus C should always be positive. So this is just that case. Let's write this quickly. So we need a vector of integer called DP of size amount plus 1, and initially let's call every value to be amount plus 1. This way we can minimize it perfectly. Then we simply say for int I equals, we need to do one thing, dp of 0 is 0. Then we start from 1, I is less than equals amount. We can even do this way. For every coins, we do this, and then we can start from C itself. Then dp of I would be minimum of dpi and 1 plus dpi minus C. Return dp of amount. If it is greater than amount, then minus 1, otherwise dp amount. Okay, let's get to the next one. Maximum product subarray. Given an integer nums, find a subarray that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. Find a subarray that has the largest product and return the product. Okay. We have 2, 3, minus 2 and 4. Now here 2, 3 has the largest product. Okay. Now numbers can be negative, and when negative is multiplied by negative, it becomes positive. So we need to take care of that. Now, for example, if I have this copy subarray, okay. Can I do some prefix product? No, I don't think so. I don't think that will be feasible. Yeah, because this is way too much. The product of any subarray in nums is guaranteed to fit in a 32-bit integer. Okay, they have guaranteed it. So if I do a prefix product or something like that, let's say 2, 6, and then minus 12, and then minus 36. Okay. Oh, this should be 48, not 36. What the fuck is wrong with me? Negative 48. Okay. What can we do here? Okay, I'm kind of stuck in this. The result cannot be 2 because minus 2 minus 1 is not a subarray. Okay. Okay. Let's see. Array dynamic programming. We have similar question. Hmm. uh Now from here, what can I deduce? I mean, first of all, I can get the most positive number, and that can be one of the answers, but okay. Right. And nums of I is in between 1 and 10, right? Or negative 10 and 10. So it doesn't go any bigger than that. Okay, I am kind of cooked. So my brain is kind of cooked. So I'll just look at my solution, previous solution. Let's see if I wrote some comments here. No comments, nothing. So I'm taking n here. Maxwell I am assuming at the 0th index, minimum value also at the 0th, and global equals nums of 0. Okay, global. Then I start from 1 till n. If it is less than 0, means if it is negative, then swap minval and maxval. Minimum value and maximum value. Maxval equals maximum of nums of I and maximum value equal maximum nums of I, or maximum value times nums of I. Minimum value equals minimum of nums of I, or minimum value times nums of I. Global equals max of global and maxwell. How do they come up with this shit, man? What is the explanation here? Now let's take a dry run of this code. Now here what we are doing, n is 4, maxval is this, so let's call it max is 2, minimum is also 2 initially, and global is also 2. Now I'm starting from here, 0 1 2 3. If it is negative, then we don't swap. Then max equals max of either this or 2 times 3, which is 6. So max becomes 6, and min value minimum of either nums of I, which is 3, or 2 times nums of I, which is 6, so it remains 2. Right? This is crossed out, this becomes 6. Now global equals max of global and maxval. And now 2 and 6, this becomes 6. Now we go again, we are here now. Now what happens? If nums of I is negative, then swap min value and max value. Min value and max value. So we swap these. So this becomes 2 and this becomes 6. Maxval becomes maximum of either nums of I, which is negative 2, or maxval times nums of I. Maxval nums of I negative 2, or 2 times negative 2, which is negative 4. So max is negative 2 now, and min is minimum of nums of I negative 2, or 6 times negative 2, which is negative 12. So this becomes negative 12. Right, global equals max of global and maxval, so it remains 6. Then we come here. This is not negative, it remains as the same. Another great day, right? Yes, sir. Another great day, another set of LeetCode questions. That's how we do it. Okay, max equals 4 or 4 times. No, negative 2 times 4, which is negative 8, so it becomes 4. And then min value is minimum of either nums of I or negative 12 times 4, which is negative 48. And this is max, this remains 6. So what are we doing? What does this code do exactly? When it is negative, we swap min value and max value. Okay, maybe we need to see the fucking solution. Explanation, right? Let's see.
Hey everyone. Product subarray. And this is actually a dynamic programming problem, and I'm going to show you how to solve this problem easily. So we're given an integer array of numbers, and we want to find the contiguous subarray that contains at least one number and has the largest product. So in this case, we have a 2, a 3, a negative 2, and a 4. And the largest continuous product we can make is 2 and 3, because 2 times 3 is 6. That is the largest product. We can't. It's like your first idea how to solve this problem. Maybe brute force, right? Is there a brute force solution to this? Well, we want to find a subarray, right? So why don't we just try every single subarray? So let's say all subarrays starting at 2. We got 1 subarray, 2 subarrays, 3, 4, right? And for each of these, let's just calculate the product, right? Like the first one is 2, the next one is 2 times 3, the next one is 2 times 3 times negative 2, the last one is 2 times 3 times negative 2 times 4. And we end up seeing that so far the biggest is this, but we're technically not done yet. All of these subarrays contain 2, so now let's look at all subarrays containing 3. So we got 1, right, just 3, then we got 3 times negative 2, then we got 3 times negative 2 times 4. And basically we repeat this process. Now, you can tell that this is not super efficient. The time complexity is big O n squared. For each of these numbers, we're going to end up having n subarrays, and we see that the total number of elements we have is also n, right? It's n elements in the array, so we're going to get n times n is n squared. So my question is, can we do better? And how can we do better? Maybe there's some patterns to this problem that we can use to our advantage to find a better solution than n squared. So let's look at one example. Do you notice anything about this subarray? Well, all elements are positive. So what does that end up doing? Like, this is all positive, so we got a 1, okay? And next we want to check this subarray, okay, multiply it by 2. We want to go even farther, check the 3, okay, multiply it by 3. And what if we kept having positive elements? 4, 5, multiply by 4, multiply by 5. Do you notice something? Up until this point, our product is going to be a 1. Up until this point, it's going to be a 2. Up until this point, it's going to be a 6. Up until this point, it's going to be a 24. Up until this point, it's going to be 120. If we have positive numbers, no matter what happens, they're going to keep increasing, right? So this is the simple case. If we get all positive numbers, then our product is always going to be increasing. So now let's actually look at the opposite scenario. What if we had all negative numbers? Because all positives is easy. You just multiply all of them, you get the max product. But with negative numbers, it's a lot more tricky. So let's look at the first number. So up until here, the max product is just negative 1. And then we add a second element, a negative 2. And then what do we get? We get negative 1 times negative 2. And we know that the product of that is 2, right? Positive 2. Now the last subarray we checked from all the way from negative 1 to negative 3. So we introduce one more value, a negative 3. And now if we multiply all 3 of these numbers together, we see that our product actually got smaller. Now it's negative 6. And what's going to happen if we had another element over here? What if we had a negative 4? Then we multiply by negative 4, and now we see that our product is going to be 24. So you see that when you have negatives consecutively, the sign is alternating. So when you want the maximum, it makes it kind of tricky to have negatives. But we also see that even though we got a negative 6 over here, there's actually a subarray that has a better solution. If you just take these two numbers, negative 2 times negative 3, we get a positive 6. So why did we get a negative 6 over here? How can we find the real maximum, which is positive 6? So even though we're looking for the max product subarray, we're actually also going to need to keep track of the minimum as well. And I'm going to show you why. So first, do you at least agree with me that if we want to find the max product array subarray of this, of the entire thing, it might be helpful for us to at least solve the sub problem, which is the max product subarray of just the first 2 elements first, and then use that to get the entire one. Okay, that makes sense. We know that the max product subarray of this is 2. Now, if we had a positive 3 over here, then we would say, okay, if I can get the max subarray of the first 2 elements and multiply it by 3, I'm going to get 2 times 3. It works when these are positive numbers, but we actually have a negative 3 over here. So I'm going to say, get the max product subarray, which is positive 2, but let's also get the minimum product subarray of these 2 as well. And what do we know about the minimum? What's the minimum product subarray of these 2? It's going to be negative 2. So I'm going to keep track of both positive and negative. So we have a positive 2 and a negative 2. We keep the max and we keep the minimum. So now when we want to compute the max product subarray, when we include this 3, then we can compute that. We can compute that using both of these values. So we know that when we take the maximum 2, we get negative 3 times 2, which is negative 6. And we know when we take the minimum, we get negative 3 times negative 2, and that gives us a result of positive 6. So we know the maximum is positive 6 and the minimum is negative 6. So we take positive 6 and put it over here, and we can take negative 6 and put it over here. And hypothetically, maybe we get another element, and this time whether it's positive or negative, right? So in this case, let's say it's negative 4, we will be able to find the solution because the minimum, or rather, we're looking for the max product subarray, and we know if we take negative 4, multiply it by the current minimum, which is a negative number, negative 6, we will end up getting 24, which is what we're looking for. But if you reverse it, what if we had a positive 4 here instead? Well, in that case, we can say, okay, positive 4 multiplied by our maximum, right? Our maximum, which is positive 6. So 4 times positive 6, we get 24. We still get it, right? So this, if we maintain the maximum and the minimum, we have all the information we need as we continue to add more elements to our array. So now let's just look at one edge case. So we're talking about positive numbers and negative numbers, but we know that one last edge case exists, the dreaded 0 value, right? So what if we had a 0 value and then maybe some other numbers, 3, 5? Our 0 is going to kind of kill us, right? It's going to kill our streak. Like, look what's going to happen to our min and max. If we take 6 multiplied by 0, we get 0. If we take negative 6 multiplied by 0, we get 0 again, right? X times 0 equals 0. And then if we try taking this 0 and making it a product of maybe 3 and 5, it's going to continue being 0, right? Because any number times 0 is going to be 0. So I'm going to decide to handle this in a different way. So anytime we get a 0 value, I'm going to reset our max to 0, or rather to 1. And I'm also going to reset our minimum to 1. And the reason I'm going to do this is because I don't want to kill our product, right? I'm just going to say that zeros are ignored. We don't really care about zeros. And the reason I'm setting this to 1 is because then when we start introducing new values like 3, it's just going to be 1 times 3, right? Which is going to end up being 3. So 1 is like a neutral value for us. So those are the main things. We want to maintain the max and minimum of our product, and we want to handle the 0 case by resetting everything to a neutral value like 1. Okay, so now let's code it out. I'm going to say our result is initially just going to be set to the max value contained in
Yeah, it's kind of a similar thing. So the trick is we need to keep track of minimum and maximum at all times, and whenever we encounter a negative value, we swap those. That is all. Okay, let's do that. It's kind of a okay. Now for int I equals 1, I is less than nums dot size I plus plus. If it is negative, then swap max value and min value. Max value equals max of, and nums of I, and max value times nums of I, right? Min val equals minimum of nums of I, min val times nums of I. Answer equals max of an answer. Okay, cool. Let's get on with the next one. Word break. Okay, now this I have I hate this question. Given a string s and a dictionary of strings, word dictionary, return true if s can be segmented into a space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in this segmentation. Okay. So one thing to do here is, first of all, put word dictionary in a hash set so that we can get it in order of one time complexity. Okay. Okay. Let's take this example. Apple, pen, apple. Okay. Okay. Um, we can make an empty string by not including any of the word dictionary. Then we check if E is present, if LE is present, if PLE is present, if PPLE is present, if Apple is present. Apple is present, then we say this is true. Then we check um, then do we check N or NAPL? N apple, pen. Pen is present. Okay. Let's see here. Cats and dog. Okay, dog is present. And dog. And dog. And dog is present. But we aren't checking and dog, right? All of the string words are unique. Okay. Okay, word dictionary length is 1000. So maybe instead of, okay, we are checking apple, right? Maybe we have to check every word dictionary. Maybe we start with E, then we check can we make a string of size 5 or 3 starting from E till the end. We cannot, right? Then we move here, we can check if PLE is present. Nope. Apple, yep. I think that was the case, right? I remember this question. Maybe. So that the time complexity will be 1000 times at every length, which is 300, right? Yeah, 1000 times 300. It's kind of a, let's see. So basically we need a DP array of boolean of size string plus 1. Then for int I equals n minus 1, I is greater than equals 0, minus minus, for every word in word dictionary. Sorting can make sense, but yeah, sorting can make sense. Sorting can optimize some shit. Word dictionary dot begin, word dictionary dot end. Sort by length we need to do first of all. Compare length. Then here we need a comparator. How did we write a comparator? I think it was a static bool compare length string const string a const string b return a dot length, should be b dot length, right? If I plus w dot length is greater than or equals n, then break, right? Otherwise then we check if s dot substring starting from I of size w is equals w, then dp of I equals dp of I plus w dot length, and at the end we return 0, right? Oh, return dp of 0, not 0. And what happened here? Okay. If I plus w dot length is greater than equals n, I think this should be greater than n, because when it is equal then we can't do true. Yeah. I think this is the solution for this. Wrong answer. A, B, C, D. A, B, C, D. What? A, B and C, D. Output false. Expected true. That is correct. Akarsh Rajput, I want to see your leetcode dashboard. Here you go, brother. This is my leetcode dashboard. Okay. Why is this false now? Okay, we are starting from 0, right? If I plus w dot length. Okay, let's see here. If there was, let's say this was pen, this is true, right? I'm here, I make a string of size 3, it's impossible, then I go here. I try to make a string of size 3, it's impossible, then I go here. I see 10 plus. I start from 10. 10 plus w dot length is greater than n. 10 plus w dot length, which is 3, 13. If it is greater than n, what is n here? The size of this, which is 13, right? It is not greater than n. 13 is not greater than n. Then we say I w dot length, if it is equals let's see, string compare in CPP. str1 dot compare str2. What's wrong here? DP. Let's see. Found CD at 2, correct. ABC. Found B at 1, correct. Found A at 0. 0 plus 1 B. Found B. CD at 2. 1 plus 1 is 2. Found ABC at... Oh shit. It should be DP of I or this, because it can be overridden by previous things. Great observation. I knew that I was missing something here. Okay, cool. Next question. Longest increasing subsequence. Okay. Given an integer array nums, return the length of the longest strictly increasing subsequence. Great question. So here we need to do some DP shit. Okay. So, okay. Is it like a n square solution? So initially in the DP array, I will say that there is, um, I just need to return the length and not the actual subsequence. So initially the length of each subsequence is 1, right? Then I start from here. I see that 9 is not greater than 10, then nothing can be done. Then I see 2 here. 2 is not greater than any of these, so nothing can be done. Then I see 5 here. 5 is greater than 2, so I put 2 here, right? Then I see 3. 3 is greater than 2, then I put 2 here. Then I see 7 is greater than 3, but also greater than 5. So it'll be maximum of whatever, right? So it can be it will be 3. Then I see 10 is greater than all of these, so 4 or 101. Now 18 is greater than 7. 4 is the answer. 4. I think this is the solution, right? Let's try this out. So we simply need a vector of int called dp of size n, and initially everything is 1. Then we start from 1. dp of if nums of I is strictly greater than nums of j, then dp of I equals max of dp of I and 1 plus dp of j, right? At the end we return dp of n minus 1. Let's see. Okay, the sample test cases pass. A wrong answer. One, three, 4, 5, 6, 1, 3, 6, 7, 9, 10. Yeah, I mean, why is this wrong? Not n minus 1, it should be maximum of everything in this. So we can keep track of max lis separately, right? Max lis equals max of max lis and dp of I. Return max lis. Let's see. No. Oh, initially 1. Okay, good enough, good enough. Let's see. Next. Partition equals subset sum. Given an integer array nums, return true if you can partition the array into two subsets such that the sum of elements in both subsets is equal or false otherwise. What? 1, 5, 5 and 11. Okay, can be in equal sizes. Okay. Wobble Bobble Studio. Question. What does that mean? Okay. Okay. Brute force approach, I see it as a recursive thing. Like, in your previous question on draw board, why you put 3 for 7 in DP? Because it is 1 plus, because we are increasing, I mean, the length of subsequence increases by 1, right? So initially all of them were 1. Means 10 standalone is an longest increasing subsequence of length 1. But when we encounter 5 and we see that 5 is greater than 2, we say longest increasing subsequence till 5 is of length 2, which is 2 and 5, right? And then when we encounter 7, we go back and see, is there anything less than 7? We see 3 is less than 7 or 5 is less than 7, so we pick up this value and add 1 to it. So yeah, that's why this is 3. So at 7, longest increasing subsequence can be 2 of these, so it can be either 2, 5, 7 or it can be 2, 3, 7. Both are valid. Yeah, no problem, man. No problem. Okay, so in here we have something recursion based right off the bat. So simplest solution will be, for every element I have two choices. Either I can include this in set A, because yeah, I just need two subsets, right? Let's call left, or let's call this set A and this is set B. So for every element I have two choices. Either I can put the element in set A or set B. Now I can do all of the possible combinations of these and check if the sum is equal, right? But that would be way too long, so it will be 2 to the power of n time complexity, which is pretty bad. Let's see if we can use some DP here. The array cannot be partitioned into equal sum subsets. Okay. Feels like some two-dimensional DP table would work, I believe. I don't know. Right? Because yeah, there are just two branches. Let's see if we can make that. So it will be size of we don't need this. So one can either be in this or this, right? I can also do one thing. I can calculate the total sum first, and then we can do something maybe. Also, the total sum should be even. Otherwise, it cannot be divided into two equal elements, right? Because the sum of this is, what is this? 10 plus 12, which is 22. That's why it is divisible. Yeah, one prerequisite is that. Now, what can we do here? Let's say the sum is 22 here now, right? I need to make 11 sum. If I include zeroth element, if I don't include zeroth element, sum remains 0. If I include it, it remains 1. If I don't include 5, yeah, this is the reason why I hate bottom up DP. Okay, let me just check one thing. Okay. I am just looking at my past solution, man. Fuck this. Okay. The solution is pretty bad itself. Okay, n is num size, sum is this. We are adding sum. If it is odd, then return false. Then target is this. Then we are creating a boolean array, 2D boolean array of n plus 1 size, and vector of target plus 1. Okay, dp00 is true. Then we are going to each element, we can make 0 by taking nothing from the array. That is correct. dpi0 is true. Then we start from 1 till n. If nums I minus 1 is equals target, if nums I minus 1 is equals target, okay, then this is the reason why I hate bottom up DP, man. Is there any memoization solution? Please help me, man. Help me. Okay, this is knapsack. Okay, time to learn knapsack. Yeah, this is classic knapsack, man. Fuck. Let's look at this guy. We are given an array nums and we need to find if we can split it. Yep, when the sum of the array is odd, then splitting it into subsets with equal sum is not possible. Correct. Okay, initialize a boolean DP array of size target sum plus 1 where DPI stores true if having some I by the subset is possible. False. DP0 is initially true as having some 0 is obviously true. Okay, iterate over the array and keep updating DPI based on the observation whether getting subset sum I is possible or not, including that number. Here we use DP knapsack logic as we have to think at every index whether we can make some I by including or excluding that number. That is 0-1 decision. We iterate from the target sum down to the current number. Num to ensure that each number is only used once during the update process. This reverse iteration prevents the same number of being counted in the okay. Okay, is he using just a single dimensional? Where is your code, buddy? Okay, he's using just single dimensional thing. Okay. Okay. Yep. Initially 0 is true and everything else is false. Then we are at this 1. Now we start reversing from target sum to num, basically 11 to 1. Okay. At current sum 1, dp of 1 equals dp of 1 minus 1, which is false or true, which is true. Correct. Then now we start looping from target sum to 11 to 5. Okay, 6. Oh, then we check. Okay. Okay. For every number in nums, we are starting from current sum, and current sum should be greater than equals num. Okay. dp current sum minus 1. If dp target sum, return true. Yeah, this is way easier. I don't know what the fuck I wrote here. Let's see if we can understand now. Okay, we have a 2D boolean, a dpij. That single dimensional knapsack is pretty good. So basically what we need to do is, we don't need all of this bullshit. We first calculate the target sum, which is total sum divided by 2. Here target sum is 11. Then what did this guy do? So this guy created a dp array of boolean of size target sum plus 1. So till 0, 11. Okay, then we are iterating over each num and trying to find if we can make every sum here. So we start from 11, and this is considered as true because we can make 0 by excluding every element, and then we just do the sum minus this number, dp and dp of current, because we don't want to override, right? So this is the equation. Let's write vector of boolean dp n plus not n. We need target sum. What the fuck am I doing? Sum equals 0 for int n in nums, sum plus equals n. If sum mod 2 is 1, then return false. Int target sum equals sum divided by 2. Then we create this target sum plus 1. Everything else is false. dp of 0 is true. Then we iterate over each number. Then we start from target sum. S sum equals current sum equals target sum. Current sum should be greater than or equals to n. Current sum minus minus. If dp of current sum equals dp of current sum mod dp of current sum minus n if dp of target sum, then return true. Return dp target sum. Okay. Yep. I need to study knapsack a little bit more. I need to do more questions related to this. So if I see here in the description, there must be a topic of knapsack or something like that. Let's see problem list, or you can go to the home page, go to problems, and then we see algorithms. Let's expand this shit. Do we have knapsack here? Knapsack. Search knapsack. Nope. Let's see. Knapsack leetcode. Okay, 01 knapsack. Okay, so I got my task for today, rest of the day, to study knapsack a bit more. Okay, this list really exposes your weak points in leetcode, so that's good. Let's see what we can do next. What is some interesting shit, man? 2D, nah. Do we hit on advanced graphs? I'm feeling some backtracking, man. Design Twitter, fuck that. Trees is done, linked list is remaining. Binary search is done, stack is remaining. So in stack it will be something like monotonic stack, monotonically increasing stack. Some questions are those, so which is fine. I'm feeling some backtracking. Let's take a look at some of these questions. Given an integer array nums of unique elements, return all possible subsets to the power set. The solution set must not contain duplicate subsets. Return the solution in any order. This feels easy. So at every element we have two choices. Either we can include it in this current set or not, right? So when we are at 1, we can either include it or don't include it. So yeah, then we are at 2. Either we can include it or we don't, right? Same shit here. And yada yada yada. At the end, whatever layer will be that, I need to just store all of these things in a result array and return that. Let's see. Okay, vector int current dfs nums starting from 0 and current, and let's create a vector of vector int result void dfs vector int nums starting with index I and the vector of int current. So simply we can check if I is equals nums dot size, then we return immediately. Otherwise, now we have two options. If we don't include it in the current, so we simply say dfs nums I plus 1 and current. And actually in the base case we need to do something more, we'll talk about it later. But here current dot pushback, so we include nums of I and then call nums of I plus 1 current, and then we pop it back, and when we reach the end we push current into the result, which will take care of all of the ending things. Let's see if this works. Okay, it works. Cool. Should I just jump directly to this? Let's try. This will, uh, this will get the brain working. Okay, the n queens puzzle is the problem of placing n queens on an n by n chessboard such that no two queens attack each other. Given an integer n, return all distinct solution to the n queens puzzle. You may return the answer in any order. Each solution contains a distinct board configuration of the n queens placement, where q and dot both indicate a queen. What? Each solution contains a distinct board configuration where q and dot both indicate a queen and an empty space respectively. So wherever there is a q, it means there is a queen there, otherwise it's just an empty space. Interesting. So we are given n, and n is just 9, so yeah. I love this question, by the way. I'm not sure how many people are on the live stream. Let's see. Okay. Cool. Okay, let's see. Now, what is considered as a solution such that no two queens attack each other? Let's take this example. You see this chessboard, right? What are the movement direction of a queen? Queen can go up and down, and queen can go diagonally, right? So how many directions are these? 6 directions. So a queen can move in 6 directions. Right? So solution of this is we just try and place a queen anywhere and call a recursive function, and that recursive function will place the next queen in any other place, and we'll check if it coincides with each other. That's all we need to do. That is why this is called backtracking, right? The only challenge here is the code is too long and we need to complete it in the given time limit. That's all. So we can structure the code in our drawing board itself. So what do we need in the recursive call? We need a chessboard, right? So in the recursive call, let's call it DFS. We need the chessboard, which is a 2D vector. We need how many queens are left, right? Right. right? Do we need the position of last queen? I don't know. What? Okay. So in the recursive call, what do we need to check exactly? And recursive call will look something like DFS with the same chessboard and n minus 1, right? And what we simply need to do is we need to create a nested for loops to go to each coordinate, place a queen, place, check if it is coinciding. If it is not, then make this call, right? When n becomes 0, that is a possible good solution. And then after placing, we remove that, right? Remove the placement. This is the backtrack call. Remove queen and then go on, right? I think this is the solution, right? Okay, let's try to write this. Okay, it's just a string, which makes it easier. Vector of strings, and we are given n, right? So initially we just need to create n strings and push it to a chessboard. Let's create that. String chess right? Anything wrong here? For int I equals 0, I is less than n, I plus plus, chess dot push back. Okay, I need to see syntax of C++ in here. String constructor in CPP. String character s and size this. Okay, so we just need a dot and size n. That's all. Then we call I mean, yeah, there are multiple ways of doing this, but I prefer this because it feels cleaner to me. Chess and n, return result, void DFS. We copy this definition, we pass it by reference int n. Now what we need to do is for int I equals 0, I is less than chess size I plus plus, j equals 0, j is less than. What? Place queen at I j. So chess of I j equals a queen. Check if it is attacking any other queen. So we need to check in all 6 directions, which is a tricky, I mean, I can write 6 functions here, So I can write 3 function, check this diagonal, and check up and down. Let's do that. Bool check straight. We need this chess, and int I, int j. Check diagonal 1, check right diagonal, check left diagonal. Bool result equals, and basically this is not check straight, let's call it is attacking straight, is attacking right diagonal, is attacking left diagonal. Now result will be ampersand of all of these three, is attacking straight, or if any of this is attacking, then we can't place there, right? Is attacking straight, is attacking right diagonal, or is attacking left diagonal. Chess ij, chess ij, chess ij. If result is true, then we can't place. If attack is true, then remove it. Or if it is not attacking, then remove it. Basically, what does that mean? Chess of ij becomes a dot again. Otherwise, we call the fucking recursive call chess n minus 1. That's all we need to do. Let's write these functions now. Okay, int I. And okay, it's 8 directions, not 6. I did a dummy thing here. It's 8 directions. Essentially 4 directions, 2 diagonals and 2 horizontal and vertical. Let's see. For int p equals I, p is less than chess dot size. Okay, let's see. Int n equals chess dot size. P plus plus, if chess p j is a queen, return true. Then for same loop, very similar, copy, paste, start from I and go till 0. Then similar loop for column, int q equals j, q is less than n, q plus plus, if chess of I q is a q, return true. Similarly, otherwise return false. Now is attacking right diagonal. Now right diagonal, I'm assuming this one, right? It goes to the right. So we do I minus 1 and j plus 1. right diagonal I minus 1 j plus 1 and I plus 1 j minus 1. And for left diagonal, what do we do? I minus 1 j minus 1 and I plus 1 j plus 1. Okay. For int p equals I, p is less than n, where n is chess dot size, p plus, let's see, what was the thing? If we are doing I plus 1, then we should do j minus 1. Okay, I plus 1 j minus 1 for int q equals j, q is greater than equals 0, q minus minus. Then if chess of pq is a queen, return true. We need one more thing. Right, yeah. And similarly for left diagonal, now if we are doing plus, we should do plus on both, q less than n, q plus plus, and then if we are doing minus, we should do minus on both. Right, let's write the base condition now. If n is 0, then result dot push back this is actually just this. I messed up big time. Messed up big time. We just need this, buddy. This was a mistake. Yup. Now if n is 0, result dot push back chess and then return. Okay, there is a mistake here. If attack is true, then remove it. Wait a second. If attack is not true, if attack is false, then then go next. This one, right? Because we have to remove it anyway. And we have to remove it anyway. So chess I j becomes a dot again. Dot. At the end, return result. Let's see. There might be errors for sure. Yep. Chess dot pushback. Vector of string. No matching member function. String. Wait a second. String constructor CPP. Okay, output is just empty. What the fuck, man? Okay. Let's first of all do this. What the fuck? The fuck is this? Do I need chat GPT? Create a string containing dot character of a given length and push it to vector string. Oh, first the length and then dot. Shit. Okay. Okay. Okay, nothing. Place queen at ij. Check if it is attacking any other queen. What? N is 4, right? 4 minus 1 if n is 0. Most likely these attacking functions have some mistake. I'm pretty sure. Yep. Always attacking. Okay, what's wrong? Is attacking straight. P equals I. P less than... Oh, shit. Shit. I can do one thing here. Either I can change and tweak all of these fucking little functions to exclude ij from checking, because we are checking ij itself, that is why it is always failing. Or I can check if it is attacking anything before assigning it to the position. If it is not attacking, then do that. Right? Not attacking, and then we call this, and we in the backtrack we do it anyway, we clear it out anyway. Let's see. Okay, not attacking, but still we are facing an empty answer. Is it this? Do we need dish? What? Okay. Do I need to tweak all of this shit? Fuck it, let's do it. So we are increasing here, we do +1, we are decreasing, we do -1, we are increasing, we do +1, we are decreasing, we do -1. Here we are increasing +1, -1, -1, +1. It's just so sad, man. +1, -1, -1. Yep. Let's see. Come on. Still empty. I wonder what's the fucking deal. Found a config. Let's see. Okay. No config is being found. Okay. Okay, we are placing queen here. What? Fuck. So n is just 3. It's not even going to 2 in any case. What's the deal about that? So my checking function is shit. Fuck. Is attacking right diagonal. I plus 1, j minus 1. Okay. Okay, R1. R2. R3. R1. R1. R3, R3, R2, R2. If R1 or R2 or R3 not R1 0, R2 0, R3 0. R1 is 1, R3 is 1, R1 is 1. Okay. Why is R1 returning true? So what's wrong? If P equals I plus 1, P less than N, P plus plus chess of Pj is equals to true return. P I minus 1, P greater than equals 0, P minus minus. Now, okay, see here, we have this, right? I, J, let's see, 0 0 0 1, R1 is 0 1 0 2 0 3, 1 0, yep, 1 1, yep, 1 2, 0, boom boom boom. Why is 1 2 returning R3? Okay, R3 is attacking left diagonal, right? What the fuck is the problem here? What is left diagonal? Let's see. I minus 1, J plus 1, I plus 1, G, I plus 1, no. What the fuck am I doing? This is I plus, sorry, this is I minus 1 and J plus 1, correct? And this is I plus 1, J minus 1, correct? Now this is I plus 1 and J plus 1, correct? And this is I minus 1 and J minus 1, which is also correct. Then what's the fucking problem here? P I plus 1, J plus 1, I minus 1, J minus 1. What the fuck is the problem here? At 1 2, why is R3 giving 1? 0 1 2. This is clear. This is also clear. Oh no, fuck. Fuck. This is bad. This is real bad, brother. So this is fine, I believe. This seems fine, but this is wrong. This is just fucking wrong, bro. So instead of this bullshit, P equals I plus 1. Oh, damn. These need to go together and not in a fucking nested loop, man. What the fuck am I doing? Q equals j minus 1, p is less than n, and q is greater than equals 0, p plus plus, q minus minus. I am so dumb. I'm very dumb. I'm just j plus 1. Q should be less than n, q plus plus. This might be the last question of today's stream because I wasted a lot of time here. Q equals j plus 1, q is less than n, q plus plus. Q equals j minus 1, q is greater than equals 0. This is in no way pretty, but I'm just writing just to get the fucking test cases going. Let's see, brother. Fuck. Should this be this? Am I missing this here? Okay. A lot of wrong solutions. A lot of wrong solutions. Okay. You know what? Fuck this. Let's see my old thing. Positive diagonal, negative diagonal. Okay, I created some cache previously, but this should work, man. Fucking hell. Okay, let me write this again. Let me write just these two functions again. And we can, okay, improve. Right diagonal, which is j plus 1 and I minus 1, right? So int p equals j plus 1 and I minus 1. I minus 1, q equals j plus 1, right? While p is less than n equals chess dot size. I'm so done with this question. While p is less than n and sorry, p is greater than equals 0. This is right diagonal. Right diagonal is I minus 1 and j plus 1. Okay, q is less than n if chess p q is a q, then return true. Otherwise p minus minus q plus plus. Then we reset. P equals I plus 1, q equals j minus 1. While p is less than n and q is greater than equals 0 if chess pq is a queen, then return true. P plus plus q minus minus. Similarly, now here it's the same thing, right? P equals I plus 1, q equals j plus 1, while p is less than n and q is less than n if shit. Okay, now I'm getting a lot of solutions. Why is that the case now? Okay. Yeah, this is correct, right? Q, 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 correct. But why am I getting way too many answers here? What's wrong? Can I just what? Q, Q, Q. Am I getting repeated answers? Why? Is this repeated? Interesting. Why am I getting repeated? Right? Because this, you see this exact string. If I try to find it, yep. 1, 2, 3, 4, 5, 6 times. Some repetition is going on, man. If it is 0, then return. Yeah. Then what's the deal here? Result dot pushback. What am I doing here? Solve left row and okay. Yeah. Can we place a queen there, then place a queen, block it, and then solve, remove the queen, unblock it? Can we place a queen? Okay, we are first checking if we can place a queen there. Okay, okay. Okay, and we are not doing in fucking what? Try each row. Okay. Where is the column thing? What the fuck is column doing? Row plus col. Where is col? Oh. Column is passed as a fucking parameter. shit. Yeah, it makes sense because since I'm starting with 0 again, yeah, it's repeating. Yep, I got it. Makes sense. Makes sense. So I can make a little change here. I can pass in coal and then try each row. We already know coal, right? So we don't need this shit. Bro, my brain is fried. Okay. Or this is J. J makes more sense. Now, continue. If this shit if is attacking straight or diagonal or the other diagonal, if it is not attacking any of these, then we place a queen at that position. Then we make the DFS call. J plus 1, and then we remove this thing, right? Then we don't need any of this. Okay. Right, and we start with the column 0, and let's see if anything is missing here. Found a config, print. No need to print, man. Yep. Now let's see if it is passing time complexity issues, because that cache was made for a reason. We don't need all of this, right? So this is pretty long, and I have most likely taken more than 20 minutes. So if this question was to come in an interview, I would have failed that, right? Okay, let's see. Hopefully I'm not doing anything. Oh shit. Hopefully there are no more C outs. Right, let's just do one thing. Okay, submit. Okay, yeah. The time is slow because we haven't done cache. So I'll try to add cache offline, off stream, and we'll continue backtracking tomorrow. Alright, so this was it for today's stream. I'll see you guys tomorrow. Goodbye and GG's.